Hi, this is how to linearize your data when you have just graphical analysis and Google Sheets. So let's say we have a graph of data that looks like this. In graphical analysis, if we were to select these points, our curve fit window comes up and we can choose linear just to kind of give us a start. We can see that a lot of the points are below that and they seem to get further away and then closer, which kind of looks like a curve. We can take a look at another thing. If you've entered these in order, you can look at the graph options and choose lines or both. And then we can kind of look at that too. We can kind of see there's a curvature to this. I'm going to go ahead and change that back to points. Again, your data have to be kind of organized for that to work, but if they're not, just leave it off. But we can kind of start, as you get used to doing this more and more, you'll start to recognize the curves faster. So the first thing we do, if we find out it's not quite linear, we can click on this and choose something else. I recommend, to get a better idea, is go ahead and choose power, especially if you notice that it's going through 0, 0. Try power, and that might give us a clue of which one to choose from there. So if I do that, I get that the equation is y equals ax to the b power, and it says that b is around 2, but look at the curve there, and you can kind of see it's kind of tracing exactly around those points. It's not perfect, but that's science for you. It's not perfect, but the idea is that we can kind of get started around a power of 2, which means we're going to be squaring values, and in this case the manipulated value is going to be squared, or x, or time. So I am going to go back and I can double check with quadratic to see what I get to, and I end up with something like this where I have, again, y equals ax squared, b is pretty much 0, c is really close to 0. So again, it's probably that we have to square the time values. So I'm going to go ahead and remove this, this curve fit here, and I'm going to click and drag on the data values here, and I can copy those and move right over to my Google Sheets. So I've already set up a Google Sheet for this procedure, and I'm just going to paste that right in. I'm going to go ahead and just use variables to represent things here for now, for brevity's sake. But the idea is we want to copy the y values. We're not going to do anything with the y values, so we're going to move those over. In fact, and I know it says x, but you can think of that as position values if we want to make that easier. So you're not getting confused which axis are we talking about. This is the dependent variable. We're going to copy that over to column D for now. And our manipulated variable is the one we're going to be manipulating and changing to see if we can get that new change with the old y values and see if we can get a straight line out of it. This technique is called linearization. It helps us find, it helps us use what we already know, y equals mx plus b for linear equations. Okay, we know that. It's harder to use the other things, but if we can change the data by squaring, for example, each data value there, we might be able to get a straight line, and we can use y equals mx plus b to get us an equation, a model for whatever was happening. So what's going to happen is that since we're squaring, my title is going to be t squared, and the seconds are going to be squared. I'm going to use the power of Sheets to do this. Of course, you can do this in Excel too, but if you're working on a Chromebook, this is all free. So the whole point of this is that we can do this with Sheets and graphical analysis. I hit equals to start us off in the formula mode, and then I press the reference that I want. I want to square that value, so I click on A2, that's column A, row 2, and then I hit Shift 6 to give you that caret, which means raise to the power of, and I put the 2. And it actually gives me a little tool tip to say that's what it's going to come out to. It's going to come out to 0. 0 squared is 0. Now I can sit there and enter and click at each one, but I can fill by clicking on this blue square on the bottom right and just dragging down, and it will automatically fill in all the squares of all the t values that you had on the left there. Our independent variable is being squared. So now I'm ready to copy this back into graphical analysis. So I'm going to go ahead and copy that, go back to graphical analysis, and add a new experiment. It's going to be manual entry. We can copy paste. So rather than import, say like on Logger Pro, if you had a computer, that's wonderful. You wouldn't have to do all these extra steps, but when you're on a Chromebook, sometimes you have to kind of work your way around things. So here we are. We're ready to go. I'm going to go ahead and paste the values in. And already I'm looking at my data going across there in a very nice straight line. It looks like we found the code, which means that we had to square the independent variable. We're going to go ahead and name those columns to reflect what we've done. The independent variable was time, and we've squared it, which means the units will also be squared. That's very important to remember that. And our y values, our dependent variables, are unchanged, and that's kind of how we would like to keep it. We want to manipulate the manipulated variable. That's the whole point. The dependent variable we leave alone. So the name of that was position, and that was in centimeters. Again, we can do all of our details that we need to do, putting our title and so on. For example, the effective time squared on position, or position versus time squared if you want to go very basic. And then I'm going to give myself a range that gives me a little bit of elbow room for my data. And then I can click out of that. Now I'm ready. I'm going to go ahead and curve fit a linear fit, and I get a much better correlation than I had before. Way better root mean square error. Of course, it's kind of comparing apples and oranges here, but the whole point is that we have a very straight line. We have y equals mx plus b. We would go back into our linear analysis, complete it by saying, okay, the position is 1 centimeter for every second squared times time squared, and we would go from there. So it looks like we have our equation, and we're ready to move on with our analysis and results and our conclusions. Excuse me. Thank you.